So if you see one of these charts, don't be too overwhelmed. It's going to be all right. But basically, this is a bunch of questions bunched up into one. Okay. So basically, the one row that's completely filled in this case, I already give it away, but this is what we call the original, right? And we're making a bunch of copies. So technically, if you go up to the shapes, the third one here is what we call the original, the OG. Right? My kids always make fun of it. I'm trying to be cool, and I try to fit it into my sentences as I talk to them. All right. So we're going to make a copy here. We're making a copy here. We're making a bunch of copies. These are reductions, as you can tell. And then we've got two where we actually enlarge the original. Okay, that's what I want you to remember. And so let's go ahead and do the first one. So this technically would be a new number one. Making a copy of the first one, of the original, sorry, and that'll be our first shape here. The first step you need to take, pay close attention to this part, is what do they have in common? If you look at the new shape and the original, they share, in this case, the radii is the same. Okay, they both have the same radius. Or not the same radius, but they both have the radius. By the way, I'm just going to tell you, this will be one-dimensional. Length, width, anything like that is one-dimensional. Area would be two-dimensional. And the volume is 3D, so that's also something to keep in mind. I could have, talking about boxes, I could have length, width, and so forth, but in this case it's only radius. I know both of them, okay? So I will figure out my scale factor. That's very important. K is radius of new divided by the radius of the original, because we have both of them. Okay, I don't need to root, I don't need to cube root, it's just going to be plugging in the numbers. So we got to go 1.35 over 7.5, and they're both in inches, so I already cancel out the units. And so you grab your calculator, and technically it's okay to just state it as a decimal, or just, but we don't want to leave it as fractions with decimals. That's not ideal. So you grab your calculator, and we just go 1.35 divided by 7.5, and that's, in this case, 0.18. I like you to use the decimal when it's not a pretty, even fraction, or a fraction that's very doable. We just use that one. Okay. Once you have unlocked it, this is your first step. The first step is to find your scale factor. Like, how did you get from here to there? How did that happen? Okay? And this is I'm going to actually circle that. It's 0.18. And do you remember what happens when we go from the original to the new? What do? We go this times the scale factor to get to the new, correct? All right. So to get the area of the new shape, all you need to do is K squared times area of original. You could use the formula if you'd like that instead, but this one is, I'm going to show you both ways. Okay. So here we have 0.18, we square it, and we multiply it by the area of the original surface area, that is, inches squared, and there you have it. Okay. So I'm going to copy paste. I'm going to raise that to the power of 2. You also have an x2 button, by the way, if you want to just quickly square something. can I just say, pay close attention to this. You know how my cursor stays up there? That's a little dangerous. You got to go arrow sideways to bring it back down. Otherwise, you're going to give it a really big exponent. So you go 0.18 squared times 706.86. Wait a minute, does that make sense? It is a reduction, so it does make sense, right? It's a smaller surface area for the small one. That's the second step. So once I had my scale factor, I went ahead and figured out that part. For volumes, volume of new is simply k cubed times volume of original. And so I take the scale factor, I cube it, and I'll multiply it by 176715. I go hat 3, arrow sideways, times 1767.15. And there's my new volume. And I don't know if you, for this particular example, if you'd like to just highlight the fact that once you know your scale factor, it's actually as easy as just multiplying the previous dimensions, either by squaring the scale factor or cubing it. But that's what happens. Okay. All right, let's do another one here. Let me see which one will I do. Yeah, we'll do this one. So this is another new. Forget about new number 1 now. That's gone. We've taken care of it. We know everything we need to know about it. Okay. What's the first step? If you don't know the scale factor, you must find that first. Okay. You scan between the new shape that you're creating and the original. What do we know for both of them? We know that the areas are there. Okay? So we can use that to determine our scale factor. So we're going to go k squared is surface area of new over surface area of original. And I know it's a little cramped there. My apologies. So k squared is this number, 254.47 over 706.86. I will most likely give you room outside of the table on a test or AC to do your work outside, and then just plug in the number here so that you're not scrambling. But I thought for this, it's pretty good to just have it in there. So we square root. So grab your calculator. You can go second x2 to call the square root. Brackets 254.47 divided by 706.86. Close it. And there is your scale factor, 0.6. That is the key to unlock and solve everything else. So we have to square root because we know the areas, okay? What do you want to do first? You want to fill in this or this? It's up to you. I'm going to go with the one-dimensional first. So the radius of the new is simply k times the radius of the original. It's just k, right? Not k squared, not k cubed, it's just k. So it'll be 0.6 times 7.5. And there it is, 4.5 inches. That is the radius of that shape, of that sphere. What else do I not know? We don't know the volume of the new one. So we have to go volume of new is k cubed times volume of original. So we take 0.6, we cube it, and you know, some of you might say, I'd rather put everything in brackets. Absolutely, there's nothing wrong with it. So if you want to actually type it in like that, there it is, 381.70 cubic. Ooh, nobody caught me on that one. Or maybe you caught it, just didn't want to tell me. What's wrong with the units just above? It's supposed to be cube. Sorry, that's my bad there. And so, yeah, both of them are cubed. There you go. Let's do this one here. This is my new, right? So we forget about 1 and 2 now. It's all about the original and then the new you're creating. Okay, this is the 4th sphere on our lineup up there. Watch this. I already know the scale factor. Ka-ching, right? This is huge. And I already know this, which is this times the scale factor. That's how you got this, most likely. You can check. Okay, 7.5 times 1.25. There you go. It's 9.375. So that's how you got it. So that's just a check. So all we need to do is fill in these two fellas here. So I think we can skip the writing out the formula, right? We can just say 1.25 squared 706.86. That's why we say that the volume of the new is k squared times the original. Okay. So just go and fill that in. 1.25 to the power of 2 times 706.86. We expect it to be larger, and there we go. 1104.47, and that's squared inches. Last one here, the volume. We already know the scale factor. So don't be thinking it's always going to be the same. I want you to understand what's happening. 1.25 to the power of 3 times 1767.15. There it is. 3451.46 cubic inches. And there you have it. Last but not least, 5. We don't know the scale factor, correct? So that's what you're going to focus on first and foremost. This is my new number 5. Which two do you know? You need both volumes, right? So what are we going to have to do to figure out our scale factor? We're going to have to use the formula and then cube root, okay? So k cubed is going to be new, so it's this big number here, 27,611.65 over 1767.15. We're going to cube root it. So math 4 to call cube root, or you can go up, arrow up until you find a cube root somewhere. 27,611.65 divided by 1767.15, and it's 2.49, which really rounds to 2.5. Okay. So now you can fill in the rest. You choose. Let's go with this one first. Area of new. All I would have to go is 2.5 squared times 706.86. I hope you can see that. Let me zoom into that a little bit. I hope that is a little better. 2.5 squared times 706.86. 441788, which makes sense. It's an enlargement, right? And then the last one here, radius of new is simply 2.5. Cat reflexes these days. Here, 2.5 times 7.5. So watch out, don't pick the one right above it. That's a common error. I get it, it's right, but you got to go back to the original because it's all in regards to the original. So 2.5 times 7.5, you get 18.75 inches. So you've done it all, basically every scenario that could possibly come your way. And for you to practice, let's try, yeah, it's kind of weird. I'm going to send you to page 52. So I'm going to ask you to write down on page 41, you tell yourself, try page 52. I'm going to give you some class time to do that, and then I take it back, okay? For now, no music, okay? So just like that. Yeah. Go ahead. Page 52. Looks like this. This one isn't as clean as pretty. So which one is the original? It's this one right here. Right? This is your original. So if you want to write new 1, new 2, new 3, new 4, that's up to you if you want to do that. Okay? And I'll look for the key so that you can check it. For now, maybe just try your best, and then we'll correct it together. Don't mind me giving you lots of examples, like working through. I know you're listening to me, and I actually like you to do your own work. But I will do this one, and then I will assign other pages. Okay? And then hopefully you try those pages that I'm assigning for tomorrow. You're doing pretty good. Okay? I'll talk more about the quiz a little later. Okay? So here we go. Page 39. Jasmine is making a kite using a model made with a scale of 225. It's 2 to 25, sorry. The fabric required to build the scale model is 20 centimeters squared. So a couple things. There's a scale, and it's talking about model. Okay? When it's model, I'm thinking diagram. Okay? Or, hold on. It's talking actual, so never mind. It is right to think of it as diagram. Because it says actual here, this is going to be, yeah, diagram, sorry. It is diagram. I was thinking new original. Diagram is the best one because of the actual. And we know that the fabric required to make the model is 20 centimeters squared. A asks to calculate the amount of fabric needed to build the actual kite in centimeters squared and inches squared. Okay, so let's see what we do here. We know that the scale factor, I would like the scale factor, and there are no units there, so this is perfect. We can think of this as 2 over 25. And we know that the top number always corresponds to diagram and the bottom always corresponds to actual. Just look at your formula and it will confirm that. Go ahead. So all of this is like information that I already know coming into this question. Okay? So calculate the amount of fabric needed. Fabric is, right, in this case it's two-dimensional. We're covering something up, so we're talking area. So I'm going to use this one. K squared is surface or area of diagram. over area of actual. Okay. Do I know the scale factor? Yes, I do. It's right here. So I'm going to go 2 over 25. I'm going to square that. And the area of the diagram is 20 centimeters squared. I need to figure out how much fabric for the actual kite. So notice that my scale factor is a fraction. I leave it like that if possible. You can turn it into a decimal, but leave it if you can. Okay? Leave as fraction. And I know some of you have done this already, and that's okay. Just enjoy the ride. Okay? So I'm going to square the top, which is 4. I'm going to square the bottom, which is what, 625? Yeah. So do that. That's the best way to go about it. And this could be your x there. So cross multiply and divide. So it's 20 times 625 divided by 4. And you get, let me see my key here, 3,125 centimeters squared. I'm supposed to turn this into squared inches, so I'll go ahead and do that. Just to refresh our conversion skills. What do I know? I know that 1 inch has 2.54 centimeters, correct? Let me double check. Yeah. I know this fact. Can I just leave this as is? No. I need to square it. Okay, that is the key for you to convert. So I'm going to rewrite it. And this is 1 squared inch. And yeah, just take that 2.54 and just square it using all decimals here. Or at least you can go dot, 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 but you use all decimals and you convert. Now we can cancel out. So it's really this times 1 divided by that. So I'm going to go 3125 divided by previous answer, and there you go. It's 484.38. That's the standard in this course is that your final answer gets rounded to 2 decimals minimum. If you want more than 2 decimals at the end, that's fine, except for money. Money has to be 2 decimals. So from time to time, I do round to 3 decimals, especially if it's a really small number. So you have fabric in centimeters squared. It's the same amount, just different units. Okay. But that's your fabric required. Amount of fabric, I should say, this or that. Okay. So when it's fabric, we're talking 2-dimensional for sure. If Jasmine made another kite using 500 square centimeters of fabric, making another kite, so you're making another version. Okay. What scale factor would be required to make the model? Assume the model is still using 20 centimeters squared of fabric. Okay, so we got to go like this. K squared, sorry, is area of diagram, area actual. Always revert back to the formula. In this case, it's squared still because we're talking about fabric. Okay. Let's plug in what we know. We want to know the scale factor, so you can't plug in a number for K. You don't know what happened to get from this to this. You don't. So we leave it like that. Diagram is 20 centimeters squared. Actual is 500 centimeters squared. Perfect. Cancel that out. And what do we do now? Square root, right? You want a red pen? Here, some color in your life. There you go. There you go. Boom. So this is a different scenario where you're actually trying to find the scale factor. Okay. So you just grab your calculator. Clear. So you can go, oh, there. 20 divided by 500. That's 0.2 exactly. Perfect. Okay, 0.2. If it asked in more formats, you could easily do that, but that's what I'm after. That's what I'm after. Fun stuff, eh? I know. You'll tell your parents all about it. Guess what we learned today? A sphere has a volume of 1475 cubic meters. If a new replica is made with a volume of that many square meters, cubic meters, sorry, determine the scale factor used. Watch this. Determine the scale factor used. So you know, right, you need to figure out what K is. And a couple things. You're making a new replica that is this. So what do we call this one then? If this is new, then this is original. There we go. You are awake. Okay, that's the original. This is my new one. Okay, so we've got both. And we're dealing with volumes, correct? Or cubic units. So you'll be using this one. Volume of new, volume of original. That's it. And plug in what you know. Plug in what you know. We know that the volume of the new, which is that one, and the original. So it's an enlargement for sure. And what do we do there? Cube root. Remember when you had to like break down your numbers into prime factors and then you would cube root? Remember that from intro? Thank goodness we didn't have to do that here, right? Cancel, cancel, right? The cube is gone there, so now we need to do this one. So math 4, so complicated. Divided by 1475. There it is, 8.75. You think Mr. Dixon planned it that way? Probably. Right? 8.75 is my scale factor. Let's not forget this part. How much larger is the original compared to, or the new one compared to the original? Let's turn this into a percentage. 875%, right? So the new shape is how much larger? 775% larger. 875 is the percentage of the new one, but compared to 100%, we went up 700. So we go 875 minus 100. So 775% larger. Not their areas, I'm just saying in general, that shape is this much larger. You want to get out of here, right? I'll do the page 40 and then we'll call it, that'll be it. And then I'll just assign some pages that I would strongly encourage you to try before tomorrow's quiz, okay? Page 40, a cargo container has been built using a blueprint with a scale of 1 to 15. Can I just remind you, right, that this is a scale factor. We turn this into a fraction, right? But at scale factor, you may not have different units. You have to do conversion if necessary. But anyways, we know that K is 1 over 15. Makes it nice and easy. We know it's a reduction. Reduction of the original or reduction of the actual. It depends on the wording. So blueprint, let's see. If the capacity of the blueprint is this, determine the capacity of the actual container. So I would consider the blueprint the diagram, and actual is obviously actual. Okay? So in this case, we do have the scale factor. We don't need to do anything with it. But we're dealing with volumes, correct? So your formula will start like this. This is how you set it up. We know this one. We know K is 1 over 15. Plug it in. So that's not what we're finding here. If the capacity of the blueprint is 588.25, so I know the blueprint has this volume. Okay, determine the capacity of the actual container. So this is the volume of the actual that we're after. See, so it's really just plug in, make sure you put it in the right place, and then figure it out. So 1 over, we cube 15, that's 3,375. Breaking everything here. 588.25. Please don't cube this side. I have a lot of students, they set it up beautifully and then they cube everything in this formula. It's like, no, only the scale factor gets cubed here. So make sure you are aware of that. So you multiply and divide. So 588.25, 3375 divided by 1. And we know we are multiplying. I don't know if you remember, right? To go from to the new, right? Or we're going to multiply here to the actual, sorry. 588 times this, your answer is a big number, 1985343.75, and we are in cubic centimeters. Okay, so 1,985,343.75 centimeters cubed. I'm not converting that. I could convert it to cubic meters, but I'm just going to leave it like that. Oh, time is running very short here. I posted the key to this. Let's just put the answer here in brackets, okay? I would strongly encourage you to try this one. Just put the numbers there. But here it is. Quiz review. Pages. And it's also getting you ready for the test already. Let me just see. I have the key ready here. One second. I just want to make sure I have the right 53 to 58. But that's not, that's mainly scale factors. But also review some conversions, okay? If you need practice with that, make sure you convert. And some Reynolds. Just remember how to do Reynolds. Whole quantities, figuring out whole quantities and all that. And I'll see you tomorrow here, first thing tomorrow, okay?